Today we're doing another example of solving first-order linear differential equations using integrating factors. So today here I have another example, and here are the steps that I talked about in my last videos. You can go check those out if you would like. I go over theory and basics in the first one, and I have another example video out. So make sure to check those out if you would like to have a little more review. Well, other than that, I'm going to just jump right into this problem. So let's begin. So the steps that we have here state that the first step to solve this equation is to check if our given differential equation is in the standard form. So let's do that. I'm actually going to bring this down here so we can look at it while we work. And then scroll down. Yes. Oops. Okay. So this is our equation, our given equation. And we just have to check if this is in standard form. So if you recall, standard form of a first order linear differential equation, it's going to be y prime plus p of t, y equals g of t. And that is our standard form. And we have to see if this whole thing is in this form. And we can clearly see that this right here is not standard form. So not standard form, not standard form, and we have to go ahead and make it, put it in standard form so we can do the next step in this problem. So the way to isolate this y prime is just to divide everything by t squared. So I'm going to do that. Y prime plus 3 t to the negative 1, y equals 1 plus t squared over t squared. And this is our standard form. And we can move on to the next step. So our next step is to find the integrating factor. And the integrating factor, if you recall, is I of t equals e to the integral of, p of t dt. And our p of t is something we get from the standard form right here. So this is our p of t. And now that we know that, we can just easily solve our integrating factor. So we just plug that in, 3t to the negative 1 dt equals e3 1 over t dt, and we know the integral of 1 over t is ln t, so we can just write 3 ln t, and this equals e to the ln t cubed, because according to log rules, the 3 is also an exponent of the whole thing. So then this simplifies to t cubed, because this turns into t and the 3 stays up there and we're left with t cubed. So this is our integrating factor. Yay. Now that we know our integrating factor, we can move on to the next step, which is to multiply both sides of the equation. So we're just going to go ahead and multiply both sides of the equation, and our equation that our standard form equation that we got was y prime plus 3t to the negative 1, y equals root 1 plus t squared over t squared. And we just multiply this thing on both sides by the integrating factor, which was t cubed. So we go ahead and do that, and we get t cubed y prime plus 3t squared y. So we were left with t cubed y prime plus 3t squared y equals t times root 1 plus t squared. Just going to make sure that's right. Yep, that looks right. So we can just go ahead and integrate this. So add the integration notations. Oops, that's not correct at all. And let's integrate the left-hand side first. So if you recall in my last example video, I talked about how the left-hand side is always going to equal the integrating factor times y. It's always going to equal that. And I will probably make a video explaining the proof as to why this is true, but this is pretty straightforward. But this is always true, and it'll always be. But this is always true, so you can just go ahead and write that out. So our integrating factor is t cubed, and y is just going to be y. And we can just go ahead and integrate the left-hand side. The right-hand side. So this looks like we need to use u sub because we have like a product of two t functions, and we can't use simple integration to solve this. I'm going to set u to, that looks like a y, sorry. I'm going to set u to the inside, which is 1 plus t squared, and we get du equals 2t dt. So du equals 2t dt. And we see that we have a t dt over here, and we also have a t dt in our integral. So we can isolate this and divide the left-hand side by, I'll divide everything by 2, and we're left with this. So now we can substitute the t dt in the integral with what we got here, which is the 1/2 du. So I'm going to go ahead and put the 1/2 on the outside and substitute the t dt with the du. So we're just left with square root of u du. So we can solve this using basic integration. So this equals 1/2 u to the 1/2 du, and we just raise that exponent here by 1 to integrate, and then divide it by that number. So if we raise 1/2 by 1, we get 3/2, and if we divide the whole thing by 3/2, you multiply everything by 2/3, and then you go ahead and raise the 1/2 by 1 for the exponent, and you get u to the 3/2 plus c. And then we can simplify this and also plug in our u, which is 1 plus t squared. So simplifying, we get 1/3, and plugging in for u, we get 1 plus t squared to the 3/2 plus c. So this is our right-hand side integral. A little messy, but I'll write it down write everything down more clearly for our fifth step, which is to solve for y. So our full integrated equation is t cubed y equals 1/3 1 plus t squared 3/2 plus c. Now we have to solve for y, and solving for y is pretty simple. You just have to isolate this y right here by dividing everything by t cubed. And you end up getting y equals 1 over 3t cubed, 1 plus times 1 plus t squared to the 3/2 plus ct to the -3. And this is our answer this is our general solution for the differential equation.